Hello everyone, and welcome to section 7.6, which is called Common Logarithms. So, we are officially being told that the common base is 10. So if I see log of 0.35, I know that is log base 10, which is one of two logs that our calculator is programmed to automatically do. We'll talk about the other one later. So if I'm asked to evaluate log of 0.35, well, I pull up my calculator, and I type in log 0.35, hit enter, and it says to the nearest 10,000th. So that is my 10th, 100th, 1000th, 10,000th. So my answer is that negative 0.4559 that I got on my calculator. So normally when we would see equations like this, I would try to get both sides to the same base, then set my exponents equal to each other. That would be great if 62 was possibly a power of 5, which it is not. So, since it is not, we are left to, well, try something else. So, we try to take the log of both sides. Exactly the way it's written, just with a log out in front. Now, take our rule of the exponent with the logs and move it out in front. Then, to get x all by itself, we're going to divide both sides by log of 5. That I can do. So in my calculator, I'm going to take log of 62. Be sure I close my parenthesis. It's going to be very important when we're doing calculations with these, so that way you only take the log of 62 and not 62 divided by other things. I don't really have to close the parenthesis at the end here, just because that is the end of my phrase. So I get 2.5643. Now if I wanted to check that, say I'm not so sure, I could take 5 to my exponent, and I do get 62. So nice thing about these, even though you might get really weird answers, you can easily check them by just plugging them back into the equation. So my answer was x equals 2.5643. Nice thing about these, even though we are getting these really funky decimals, you can very easily check your answers, which I do recommend, just because if you forget to close a parenthesis or misclick a number, it can be very easy to throw your answer off. So if you have the time, take the few seconds just to double check your answer. Now, what about a problem like this? Again, normally we would try to get both the 5 and the 10 to the same base. Not going to happen with these. This will look very unpleasant, but mathematically it should make sense. So just like we did above, we're going to take the log of both sides. Just like we did above, bring down our exponent. Now, besides the fact that this isn't an equality, it does have x's on both sides. When there are x's on both sides, that's when things at least look a bit ugly. So I want to get x all by itself. So there's one on the left and one on the right. In order to get the one on the right sort of on its own, I do have to distribute this parenthesis. So my left-hand side stays the same. I'll distribute my x, and then I'll distribute my negative 2. Now I'm going to get my x's on the same side. these are not the same, so I just can't say 2x. I do have to make it look a little bit uglier than that. So now I'm looking and I see, well, these both have an x in common. So let's factor out an x. And now we have the joy of dividing both sides by this quantity. Though it looks a bit ugly just because there's a lot sort of going together, it does make sense. I mean, if this was just 5 and this was just 10, we would do the same thing as if it was algebra 1. So now I have x is less than all this stuff, which I can just type into my calculator. I just have to be careful with my parentheses. So I want, and just to be sure, I'm going to group as much as I can. Some of these things are unnecessary. For example, I really didn't need that initial parenthesis, but it's better to have more parentheses grouping things together than too few. For sure, you're going to need a open parenthesis when you're talking about the denominator. Close your parenthesis after the 5. And we get a lovely long decimal as we've been seeing, and we want 4 decimal points. So we get negative 1.8233. If you wish to check it, you just plug it back into the original and see if it makes sense. So if I stored that for x, just because it's going to make my life easier when I plug it in, if I took 5 to the 3x, and the new OS will, kind of group that exponent together, but the old one will not, so you just have to make sure you have your parenthesis. And if we compare this to 10 to the x minus 2, we get the same gross looking decimal. So we know our answer looks good. Change of base formula allows us to evaluate logs that we do not have a way of manipulating. The best way, I think, to remember which one goes in the numerator and which one goes in the denominator, and these variables are completely arbitrary. They don't mean anything necessarily in particular. Whichever one, when you underline log, is completely above your line is your numerator, and the one that typically gets cut off a little bit is in your denominator. So ideally, we'll be taking just the plain log of both of these, just because our calculator will do that for us. I can theoretically take it to any base that I wish, but typically we'll either do it to the base of 10 or the base of e, just because those are the two our calculator will do for us, which is going to come in much more handily than most other bases. So if I was going to be looking at these, 140 is in my numerator, so I've got log of 140 over log of 5. That is that expressed in terms of common logarithms. So if I was going to type that into my calculator, I've got log of 140. Again, be careful that you close your parenthesis, because if you make a mistake anywhere in the calculator, it's going to be because of that, is 3.0704. And again, just because there is that room for error, you can always check. think about what this means. 5 to what exponent is 140? So I can always double check this by saying, hey, what's my base to my exponent? And I got 140. So I'm in good shape. And just for another one for practice, and if I underlined log, 16 is going to be my numerator. So in my calculator, I am going to type in log of 16 divided by log of 7 to 4 decimal points. Just to check, 7 to that exponent does indeed give me 16. So, key things to definitely remember: check your answer, and also close your parentheses. And checking your answer will make sure that you did indeed close your parenthesis. So, that's it for 7.6. I will see you in class.